Students, in our last class we have discussed about projection of points. Now today we are going to discuss about projection of lines. We must remember that line is nothing but the shortest distance between 2 points. The projectors of a straight line are drawn therefore by joining the projections of its endpoints. The possible projections of straight lines with respect to vertical plane and horizontal plane in the first quadrant may be drawn as follows. First, it may be perpendicular to one plane and parallel to other. Okay, so one straight line may be perpendicular to one plane and parallel to other. So if this is first quadrant, we are drawing only first quadrant. So in this first quadrant, the straight line may be present like this. That means this is perpendicular to the vertical plane here. This angle is 90 degree and parallel with the horizontal plane. Otherwise, the point may be, the straight line may be present like this. So in this case, it is perpendicular with the horizontal plane and parallel with the vertical plane. The second way, we can write it can be parallel to both the planes. So number 2, we will write parallel to both the planes. So if it is parallel to both the planes, then its position may be so obviously one and only option is like this. This is a line, so it is parallel to both vertical plane and the horizontal plane. Next, number 3, it is parallel to one plane and inclined to other. So parallel to one plane and inclined to other. So what may be the position? So the position may be, suppose this is parallel with the vertical plane and inclined to the horizontal plane. So its position may be like this. So this is the inclination angle theta with the horizontal plane and it is parallel with the vertical plane. And the fourth option is it is inclined to both the planes. So it may be inclined to both the planes. So suppose, think about this particular straight line. It was first at this position. Okay, it was first parallel to both the planes. Then we have rotated it by certain angle theta. So then this is the next position of position as mentioned in point number 4, that it is in as point number 3, that it is parallel to one plane but inclined to the other. This is the position. Next thing what we can do, we can make it inclined to both the planes. So now this angle is particularly these two angle, okay, is basically 180 to one another. So if you rotate it again by some angle phi, okay, we are rotating it by means of this axis. Suppose this is z axis, so we are rotating it by z axis by angle phi. Then this new line, it is in angle with both the planes. After this discussion, we are introducing two terms. One is true length and the other is apparent length. Now what is true length? Now true length is basically when any straight line is parallel to a plane, then if you project it on that plane, then it will show the actual length as it is. Then this length will be called as true length. So suppose in this case, okay, this red straight line AB, this is parallel to VP as well as parallel to HP. Now think about this straight line AB, it is parallel to VP. Now if you project it on VP, then we will see the actual length of AB. We'll get it here, okay, because it is 180 degree to the vertical plane. Now think about the straight line A B1, okay, which we have rotated by angle theta by means of this x axis. So after rotation, the position is AB1. Now if you project it on horizontal plane, obviously we will not get the true length. What will be the length? If this length is L, this angle is theta, so we know from the concept of mathematics that this length will be L cos theta. So this L cos theta is the apparent length here, okay. So these two things we have to remember, that when we will get true length and when we will get apparent length. So let us take one example first. A line AB 50 millimeter long is perpendicular to vertical plane and parallel to horizontal plane. Its end A, one end A, that is 20 millimeter in front of vertical plane, and the line is 40 millimeter above the horizontal plane. We need to draw its projection. So for concept, we will first draw the three-dimensional view. So this is the vertical plane, and this is our horizontal plane. Write V and H here. Okay, and the line AB, it is 50 millimeter length, 50 millimeter long, and what is the position? 20 millimeter in front of the vertical plane. So Suppose this is a straight line. A point is here, B point is here. This line is perpendicular with VP and parallel with HP. It is 20 millimeter in front of the vertical plane. So suppose this is the vertical plane. This is the distance between vertical plane and A, and this is nothing but 20 millimeter. And the line is 40 millimeter above the horizontal plane. So both the points A and B, we need to now draw the projections. So observer will be here for the front view. So what he will see from the he or she will see from the front, he will observe only a single point. Okay, so here on this plane you will observe only a single point. So basically A and B will be merged with one another, and if the observer observes from the top, then it will be looking like straight line, and its length will be the true length. So these two things we have to understand, and we need to draw the projection in our actual manner. So what we do basically, these two planes, horizontal plane and vertical planes, we need to make it coplanar. So our previous discussion we have already said that we are allowed to rotate horizontal plane by 90-degree clockwise rotation. So we will rotate this horizontal plane 90-degree clockwise rotation, and this will be moved to this new position. So consequently this point will be moved to here, this point will be moved to here. So this will be the position, and you can, by a projection line, you can join these two, and this is XY. So on a single plane, this is our projection, and this only we have to now represent. Now what is this length? 40. So you will draw principal axis XY first, then we will draw this point at how much distance from XY? 40 millimeter. So at a distance of 40 millimeter you draw this point XY. Now this particular point is actually representing 2 points. Okay, so 2 points means B and A. So which point is nearer to the observer? B is nearer to the observer. So we will write B prime first. Why prime? Because it is front view, and point A is also there, but it is behind B. Okay, from here, from the observer, it is behind B. So that is why we will write A prime in bracket. Then we will take our 2H pencil in order to draw the projection line. Then with this 2H pencil we will draw projection line up to how much? Now up to 20 millimeter, because this gap is 20 millimeter. Okay, so up to 20 millimeter we have drawn the projection line. Then we will draw this particular point. This point is A. Then we will draw A here, and after that we will complete the straight line. What is the length of the straight line? The length is 50 millimeter. So we will draw the 50 millimeter straight line, and our drawing is complete. We will write VP here, we will write HP here. This is the front view, this is the top view. Then we need to dimension. This length is 40 millimeter. Follow any method of dimension, either unidirectional or aligned. We are using unidirectional type of dimensioning here. Okay, this is 20 millimeter and this length is 50. So your drawing is complete and this figure will be the final answer in our drawing sheet. Next problem. A line CD 30 millimeter long is parallel to both the planes. The line is 40 millimeter above horizontal plane and 20 millimeter in front of vertical plane. We need to draw its projection. So for building up our concept at the very beginning, we will again draw the three-dimensional view. So first let us draw the vertical plane, then draw horizontal plane. Write V for vertical plane, H for horizontal plane. And our straight line is parallel to both the planes. So suppose this is our straight line CD. It is parallel to both the planes, but at a distance of 40 millimeter from HP. So if you find out this distance, so this is 40 millimeter and 20 millimeter distance with the VP. So this distance, this is 20 millimeter. Now we need to draw its projection. Now the observer first will present here and see it on the vertical plane. So it will be the view, and obviously as it is parallel with the vertical plane, the true length will be visible. Second time, for top view, the observer will be present here, and at this position it will be observed like this. So again it will be a true length. Why? Because it is parallel to horizontal plane also. Now this is C prime, D prime. Why? Because it is front view. This is C and D because it is top view. Then we need to rotate the horizontal plane by 90 degree clockwise rotation. So we will rotate it. New position of the plane will be this, and this one will also be rotated. This one will also be rotated somewhere. This will be the new position of CD, and this is the XY. So this particular thing is our drawing sheet, and this we need to draw. So we will start with XY, principal axis or reference line, then 20 millimeter above XY we will draw a point C first, then at a distance of 30 millimeter in this direction we'll draw D. So this is nothing but C prime and D prime of 30 millimeter length. Then we'll draw projection line. First up to this Projection line will be made by 2H pencil, continuous thin line. Then we will extend it up to how much length? This length is how much? Now this length is 20 millimeter. So up to 20 millimeter we will extend. This will be the new position of C and D. We will join it, right, C and D. Then we need to dimension. This is 40. This is 20. And this length is 30. The true length available in both the planes. Also you can write vertical plane, horizontal plane. It is front view, it is top view. So this problem is also completed. We'll do next problem. A line AB is 40 millimeter long, is parallel to VP and inclined at an angle of 30 degree to the HP. The end A is 15 millimeter above HP and 20 millimeter in front of VP. We need to draw the projections. So first we will start with the three-dimensional view. This is vertical plane. This is horizontal plane. Our straight line is parallel with vertical plane but at an angle with the horizontal plane. How much angle? 30 degree angle. So this can be a position. Suppose this is AB. This angle is 30 degree to the horizontal plane. Now what is the distance with vertical plane? This distance with vertical plane, it is 30 millimeter, and distance with the horizontal plane of end A, it is 20 millimeter. It is not 20 millimeter, it is 15 millimeter. 15 millimeter above HP. A is 15 millimeter above HP. So this length A, this is 15 millimeter above HP, and this length, it is not given, but we don't need to worry because it will automatically be available to us. So observer will be present here first to see the front view on the vertical plane. He will observe this view. We will write it as A prime, B prime, and tell me whether it will be true length or apparent length. Yes, obviously it will be true length because it is the parallel, it is parallel to the vertical plane. So in front view it will be true length. Next time for top view, the observer will present here. Then he will observe this much. So you will write AB, and obviously this length is not the true length because we have some angle with this plane, and from mathematics we know this length is how much. Now this length is AB cos 30 degree, but we don't need to calculate it here, okay, because this is engineering drawing, so we will not calculate anything mathematically. Okay, we don't need to calculate anything mathematically. Okay, but it will automatically be represented. It will automatically be represented there. Now we need to rotate it 90 degree clockwise. So this will be the new view. So directly this time we are drawing XY reference line or principal axis, and let us start with this point A. So from reference axis, take a very continuous thin line at a distance of 15 millimeter, then draw an angle of 30 degree here, and this 30 degree line will be how much length? Length of AB is 40 millimeter given. So this is A prime, B prime. This is basically continuous thin line, and this is continuous thick line. Now extend it to how much distance? Now distance with the vertical plane, this distance is 30 millimeter, sorry 20 millimeter in front of vertical plane. Okay, this is 20 millimeter in front of vertical plane. So extend it up to 20 millimeter, extend it up to 20 millimeter and join this. This will be AB. So our drawing is complete. Now this length we know, true length, okay, and how much? This is 40 millimeter. Okay, I am not using proper dimensioning rule here. Okay, don't be confused. Better you use 40 like this. Okay, and or otherwise you write true length, then in bracket 40. Okay, in by proper dimensioning rule, and this length is apparent length. Okay, so this length I am showing how you can dimension it by unidirectional method. So this length is apparent length, and you write apparent length is equal to, you measure it by scale and you write that this much is our apparent length. This distance is 15 millimeter, this distance is 20 millimeter. So this drawing is complete. So next problem, a straight line AB is 40 millimeter long, inclined 30 degree to the horizontal plane and inclined 40 degree to the vertical plane. The point A is 15 millimeter above horizontal plane and 10 millimeter in front of the vertical plane. We need to draw its projection. Okay, so first let us draw the three-dimensional view. This is the vertical plane, this is horizontal plane. So first draw the straight line. Suppose this straight line is parallel to both the planes. then we will rotate it by 30 degree with respect to horizontal plane. Okay, we will rotate it by 30 degree with respect to horizontal plane. So if we want to rotate it with respect to horizontal plane, then axis of rotation will be this axis. So new position of the straight line will be this one. Next, we need to rotate it by 40 degree with respect to vertical plane. So if you want to rotate it with respect to vertical plane, then axis of rotation will be this one. So again rotate it by 40 degree so this is the new position. Now we need to understand that it is inclined to both the planes. So in both the planes we have the apparent length of it. So methodically how we can progress? Now first you draw xy, the reference line. Then this is the HP, you mark it. This is VP, you mark it. Now what is the distance with horizontal plane? Distance with horizontal plane of line of point A is 15 millimeter. So 15 millimeter. Distance with horizontal plane take at 15 millimeter. And distance with the vertical plane is 10 millimeter. So take these two distances, mark it as A prime, mark it as A. Now what is the angle with vertical plane? The angle with vertical plane is 40 degree. So this angle with vertical plane will be visible here on the horizontal plane. So you need to draw a 40 degree inclined line with the vertical plane or with the reference line. And this line, what will be the length of the line? Length of the line is given in the problem, 40 millimeter. So 40 millimeter long line. And this is B1, mark it as B1. On the other hand, on VP, you draw a line that is inclined to 30 degree because the straight line is 30 degree inclined to horizontal plane. That is why 30 degree you can see here on vertical plane, okay, opposite. And you draw a B1 prime 40 millimeter long. Okay, our next duty is we need to draw projection from B. So we will draw projection from B up to this level. Okay, so you draw horizontal line from here and you project it on this horizontal line and mark it as B2. In similar manner, you take projection from B1 prime and take up to this horizontal line, mark it as B2 prime. Now obviously then you need to extend it. So you extend the line up to here, but it will not match. It may or may not match. Then you draw one horizontal line here on this level. Another horizontal line here. And you take this reference, take a compass, make it center, A1, A prime, make A prime center, and draw the arc. The intersection point here will be B prime. Similar manner, you extend this line up to A B2. Again you make A as center and take the arc to intersect this particular line. You can write this is path of B1. This line is path of B1 and this line is path of B1 prime. That means by this path B1 will travel if you rotate it, and by this path B1 will travel if you rotate it. Now A and B2, A and B prime is the final front view. So draw it with continuous thick line, and this point is B. So join this also. This is the final top view. Join it with continuous thick line. Now you can join B and B prime by a vertical line. So this is the final shape of the projection. Now dear students, if you have any doubt regarding any problem, so you can ask me in the comment. Thank you for watching this video.